Which graph would satisfy the Hooke's law under the elastic limit? This is a load extension graph, and I explained it in my video. The graph that satisfies the elastic limit. This is the graph. It looks something of this nature. The graph that satisfies the Hooke's law under the elastic limit looks something of this nature. From here to here is the proportional limit, and then we have a curve kind of here. So at least under the elastic limit, we still have something of this nature. We still have this. We can't even have this, and then we can't even have this. The same thing, we can't even have this. So obviously, this is the answer. This is the graph that satisfies Hooke's law under the elastic limit. Let's go to the second question. Another way to find this is to use the formula. According to Hooke's law, the stress is proportional to the strain. So we can have something of this nature. It means that the Young's modulus or the elastic modulus is the ratio of the stress to the strain. The stress the stress is force over area. Okay, let me just go straight from here. The stress is force over area. The stress, this is force over area, and is equal to the elastic limit and then the strain, and strain is given as the fractional increase, which is this. So from here I can make f the subject of the formula, so we have f, which is equal to delta L dot E A all over L. So it implies that F is proportional to delta L. This is the load, which is the symbol for L, which also represents the force. Then the extension is delta L. So it is a proportional graph, and this is truly a proportional graph, a straight line. So this is correct. Let's have in this question, stress is given as y, that is, stress is being represented on the y-axis, while strain is represented on the x-axis. The relationship between the stress and the strain from point 0 to point 3 is given as a linear equation. This is it here. Y equals to 3x plus 1, x equals to 0 to 3. So we represent it by a linear equation, a linear line, a straight line. Now the other one, which is in the region x greater than 3, that is from x onward, we have a quadratic equation. So we are going to represent it by a curve, since it is given by a quadratic equation. Now the question says, in which region is Hooke's law valid? Hooke's law is valid whenever there is linearity. Hooke's law is valid whenever there is linearity, because Hooke's law states that force F is proportional to the extension, or the stress is proportional to the strain. It deals with proportionality, and proportionality is about linearity. As a result, the region where Hooke's law is valid is from x equal to 0 to 3, which is option A. The question is, a nylon rope 24 millimeter has this breaking strength. If you are not sure what breaking strength is, if you check the unit, you should be very sure that it's a force. It talks about the force, 120 kilonewton. Now, this is a relationship question, the relationship between the breaking strength and the diameter of the rope. I would really like it if you can pause this video and attempt this question. Let me see your answer in the comment section. Then let's compare with this, the final answer we'll arrive at here. Okay. The breaking strength, which is the force, is given as 120 kilonewton. That's 120 exponential 3 Newton. Then the diameter is given as 24 millimeter. Okay, can I erase this? 24 millimeter. All right. What is the relationship between the force and the diameter of a body in this case? Now, the relationship stress, which is given as force over area. So, I can rearrange this equation in such a way that I will have something of this nature. If I multiply both sides by A, if I multiply both sides by A, I will have SA, which is equals to F. Then if I divide both sides by S, I will have A, which is equals to force over the S, which is the stress. In other words, I can say that F is proportional to the area. That means to the area, but area can be given as pi d squared over 4. That means diameter is inside area, but diameter is squared inside the area. So it means that the relationship between force and diameter is the square of the diameter. So we have a force of 120 kilonewton, 120,000 newton to be equal to the diameter. So we are going to have the square of the diameter. 24 millimeter, we can have it as 24 exponential minus 3. So we are going to have something of this nature, 24 exponential minus 3 squared. If 120 kilo gives us 24 exponential minus 3 squared, then how much will 12 millimeter give us? So 12, let's assume it will give us x. Then we are going to have this 12 millimeter, that's 12 exponential minus 3 squared. Now, if we do some sort of multiplication here by doing stuff like this, then our value of x will be 120 kilo multiplied by 12 exponential minus 3 squared. 12 exponential minus 3 squared. Then divided by 24 exponential minus 3 all squared. Then our value of x will be this. That will give us 30,000, which is the same thing as 30k Newton. Alright, that is it for 12 millimeter diameter. Now put in the comment section below your answer when you try with 22 millimeter diameter. Let's see what you will have for 22 millimeter diameter. I'll be expecting your comments. The toughness of a material is equal to dash area under dash part of the stress strain curve. The toughness of a material is the ability of a material to absorb energy before failure. So, the value of the toughness of a material is the entire area under the stress strain curve. So, it implies that another way we can say that is that it is the area under the plastic and the elastic region. So, before failure. So, the answer to this question is C. Both. That is the answer. Both.